Hello, children. So let's get started, or let's rather continue with our revision of polynomials. So this is the 12th PYQ. Now here the polynomial is given and you have to find the value of alpha square plus beta square. So as already told in the recap video, alpha square plus beta square. Whenever you have to calculate, we don't have to calculate alpha beta separately. We can use alpha plus beta whole square minus 2 alpha beta, because this is as good as getting alpha square plus beta square. So you have to just put the sum of the roots here and the product of the roots. So if I look at the polynomial here, the sum will be minus b by a, so which will be just a here, and product will be c by a, so which is minus b. So you get a square plus 2b as the answer here. So moving on to the next one. So this is a case-based question. So let me just try to increase the size. Yeah. So look at the graph here. What is the shape of the curve EFG? So the point E, let's say this is the point E. Yeah. So the shape of the curve EFG is a parabola. So this was part A, subpart. If the curve ABC is represented by this polynomial, so this is the inverted parabola ABC, which is given by minus, let's say it is Px, is given by minus of x square plus 4x plus 3. So remember to equate it to 0. And you can nullify the sign on both the sides. So you will get x square plus 4x plus 3 as 0. And then this is very easy. X square plus 3x plus x plus 3. Or you can say x into x plus 3 plus 1 into x plus 3. So we'll get x as minus 3 and minus 1. These will be the zeros. Now, if the path, so let's say this is your A, this is B subpart, this is C. If the path traced by the car has the zeros minus 1 and 2. Now, zeros are given, minus 1 and 2. So we discussed whenever zeros are given and if we have to trace the polynomial, what we can do? If minus 1 is a 0, then x plus 1 will be a factor. If 2 is a 0, then x minus 2 is a factor. So that is one way of creating a polynomial, and we can just multiply this to get x square minus 2x plus x minus 2. So I'll get x square minus x minus 2, x square minus x minus 2 as the polynomial. You can also do it by another method of taking the sum and the product and then using the formula of x square minus sum into x plus product is equal to 0. So which I'll explain. So I'll do the part F by that method. The number of zeros of the polynomial representing the whole curve. So if you look at the whole curve, how many zeros are there? 1, 2, 3, 4. Because we know the zeros are the points where the polynomial cuts the x-axis. The distance between C and G. So where is C? C is at minus 1 and G is at 5. So you have to go 1 unit here and 5 units here. So total of 6 units distance you have traveled. The quadratic polynomial, the sum of whose zeros is minus 5 and product is 6. So again, sum is minus 5, product is 6. So we know that if we know the sum, and if we know the product, the polynomial can also be represented this way. So sum is already given as minus 5 and product is given as 6. So this becomes x square plus 5x plus 6. So this is part A. All right. Now let us look at this case study, which has come so many times. And this is one very good case-based question to understand all the concept at one go. So now the parabolic path is given for a ball which is thrown in the air. And instead of x, t is given on the x-axis. So basically this is the function h of t is given as 25t minus 5t square. Now let's see what does they ask. Write zeros of the given polynomial. Now it's very simple. Zeros are all already given you, right? They are already given to you here. So the zeros will be 0 and 5, right? So x is equal to 0 and x is equal to 5 are the two zeros because the parabola is cutting at 0 and 5. Find the maximum height achieved by the ball. So the maximum height is this, and the coordinates for x are given to be 5 by 2. Instead of x, we have t here. So the coordinate of t is given as 5 by 2. So if we substitute t as 5 by 2 here, basically, then whatever output this polynomial will give is going to be actually this height corresponding to this input. So this will be 125 by 2 minus 125 by 4. You can take LCM as 4. This will be 250 minus 125 by 4. This will be 125 by 4, which will be 31.25 meters. Then the third part says, after throwing upward, how much time did the ball take to reach to the height of 30 meters? So again, we already have the polynomial with us, 25t minus 5t square. The question says to reach a height of 30. So that means the output of polynomial is given. So we will equate it to 30. We will form the equation as 5t square minus 25t plus 30, and to find the zeros, we'll equate it to 0. Let's divide the whole thing by 5. T square minus 5t plus 6 is equal to 0. So this becomes t square minus 3t minus 2t plus 6 is equal to 0. And this becomes t into t minus 3 minus 2 into t minus 3 is equal to 0. So t is equal to 2. T is equal to 3. So basically to reach a height of 30 meters, so this was already 31.25, right? If you analyze this, so 30, let's say somewhere here. So basically you can see, right? One time going up, one time coming down. So at two values of t, it will be at 30. So let's say at t equal to 2, at t equal to 3. So the OR part says find the two values of t when the height of the ball was 20 meters. So exactly the same question. Just instead of this 30, you have to substitute as 20 here for the value of ht and solve the polynomial. So nothing major about the last part. Still, I'll just show this will become 20 is equal to 25t minus 5t square. And I'm very sure students can solve this now. And you will get t as 1 and t as 4 for this part. If you still don't get this one, please do let me know. Thank you so much.